Cthulhu foughten, my friends and cultists. Alhazred here, back again to teach you more of the eldritch magic of malware. Today, we're going to be continuing our exploration of process injection techniques, and we're going to be discussing a somewhat more advanced one from the first video in this series. It's called Early Bird APC Injection. Now, if that sounds intimidating, honestly, it shouldn't be. Much of what we discuss today will be a repeat, or at least very similar, to the create remote thread example I showed you in the first video in this series, with really only a few new API calls involved. However, I do deeply recommend that you watch the first video before this one, because I also give you a much more in-depth primer to the Windows API in general in that video, as well as to NIM, the programming language I'll be using. So, if you're lost, go check that out. As always, all of the code discussed in this video can be found on my GitHub and is linked in the description below. I'll also include some helpful links down there for reading on the topic at hand, as well as links to relevant documentation on the subject. Beyond that, I've got just a few slides first to establish the theory. Let's gain some brain wrinkles. So right off the bat, you're probably wondering why there's a giant, naked, ugly baby bird on your screen. And bear with me, because I'm going somewhere with this, or at least I think I am. But while I was working on creating the content for this video, I just found the technique that I'm about to showcase to you weirdly evocative of certain life systems, specifically those of some birds, and even more specifically those of cuckoos. This is a cuckoo, as it happens, this ugly, naked nightmare. And cuckoos are an entire family worth of birds, composed of many genera and species underneath that. But many of those, notoriously, are what's known as brood parasites. What does this mean? Well, brood parasites are essentially the bird version of double income, no kids. D-I-N-K. Dink. But they have decided they want to have kids too. So what they do is, rather than building a nest and going to get food and bringing it back to the young and spitting it into their mouths, you know, all those things that the very entitled children expect us to do for them, these birds simply go, well, there's nests everywhere. I'll just lay one in one of those. So they lay their eggs in the nests of other birds. And the hatchlings, the cuckoo hatchlings, first of all, hatch sooner on average than other birds. And also they're much larger, as you can see in this image here. And traditionally, the cuckoo hatchling then ejects the legitimate eggs or live hatchlings from the nest, so that it can be the only recipient of the parent's food from that point on, and thus grow extremely quickly, reach full size earlier than you'd expect a bird to reach full size, and then go out on its own and repeat the cycle. It's grotesque, it's disgusting, but many of these life systems are the inspiration for similar artificial systems. And many systems in cybersecurity, this is why we call viruses, worms. These segments of code have behavior that mimics life systems, and we hearken to those life systems. Anyway, I just thought that was interesting. I bet you didn't think you were going to get a lesson on bird biology today. Certainly not gross bird biology. But you know what? I have to use my biology degree for something. So now at least you know what you're potentially getting yourself into in future videos. Anyway, asynchronous procedure calls, APCs. Now, Windows threads have what are called APC queues for functions that will only execute under certain thread conditions. Now, we're not going to talk about what all those thread conditions are. Suffice to say, there are quite a few ways to execute shellcode using asynchronous procedure calls. The technique we're going to discuss in this video is only one such method. Specifically, it's a method that revolves around the following quote, which is stripped straight from the Microsoft documentation on the QueueUserAPC API call, which we'll be talking about more in just a little bit. If an application queues an APC, an asynchronous procedure call, before the thread begins running, the thread begins by calling the APC function. Now, what does this mean from a practical standpoint? Well, if our malware starts a new process, but starts it in a suspended state so that it doesn't start executing, queues the shellcode as an APC on the main process thread, then resumes the main thread, the shellcode will execute, and effectively, it will execute in lieu of the main thread, because the main thread doesn't execute until our shellcode finishes executing, and our shellcode doesn't finish executing until our shell exits. And then when our malware finishes, it's going to close the thread, close the process, so effectively the main thread will not execute at all. We will essentially throw the hatchlings out of the nest, if you will, and execute our own code in its place. This is somewhat similar to another technique you may have heard of called process hollowing, where instead of going through the process of creating an asynchronous procedure call, we just suspend the process, we replace all of the process's code with our own malicious code, and then we just resume the thread again. And then our code effectively has supplanted the legitimate process. This early bird QueueUserAPC is a little bit stealthier than create remote thread, mostly because it's more normal for applications to call QueueUserAPC. Asynchronous procedure calls are a normal function of Windows, and processes are calling them all the time, even on other processes. So it's not quite as suspicious to call an APC on another process than it is to create an entire thread in that other process, if that makes sense. So, to walk you through the overall process that we're going to be going through, the procedure, if you will, that we'll be following when we start looking at the code. First, we're going to call the create process API, which is an API call we haven't seen yet, but don't fear, I'm going to walk you through it. We're going to call the create process API, and we're going to use that API to not only create the process, but create it in a suspended state. As in, the process is going to be in memory, it's going to be there, it's going to be fully formed, but it's not going to have started executing yet. And while it's suspended, we're going to call virtual alloc to allocate virtual memory inside of that process. Just like we did with create remote thread, we're going to allocate some memory in that process. Then we're simply going to write our shellcode into that memory. And then we're going to call QueueUserAPC. So far, this part is almost identical to what you saw in create remote thread. Instead of calling actual create remote thread, we're going to call QueueUserAPC, which is going to queue up our malicious code as an APC on the main thread of the process. Then we simply have to resume the thread, and per the Microsoft documentation, when the process starts executing, it's going to go, oh, I have APCs. Let me take care of those first. And it's going to execute our malicious code and never actually execute the main code. So again, we'll have thrown the hatchlings out of the nest, thrown the other eggs out of the nest, and taken all of that bird spit for ourselves. Now, that's enough of the slides. Let's hop into the actual meat. Let's get those actual brain wrinkles. Let's look at some code. So here we are in the code, and as before, there's a lot of text on your screen right now. But understand that everything that's in green, all of this stuff, all of those is comments. None of that is code. I've just painstakingly commented every single line so that those of you who want to read through the code and understand what every line is doing can have my comments to help you out with that. You have the comments, you have the links to the documentation, I'm providing you with the tools you need to understand the code that you're presented with. All right? Now, we're not even going to be belaboring a lot of the code that you see on your screen right here. Because a lot of it is stuff you already saw. You saw it in the previous one, the create remote thread example. Again, if you have not seen that, go back and watch it so that you, if you need to know what that code does. Here's essentially the equivalent of if name equals main in Python. This is how nym does it, and it's going to call the inject QueueUserAPC function, which is the main heavy lifter function, which is we'll get to in just a second, with our shellcode. The shellcode is right here. It's generated with MSF Venom, just simple Meterpreter shellcode. You can use any shellcode you want. I just used Meterpreter because that everyone's going to have access to MSF Venom. And it just simply passes that shellcode right here to inject QueueUserAPC. And this is the main function we're going to be focusing on. But even most of this function is not really an issue to us because you guys have seen virtual alloc ex, you guys have seen write process memory, you've seen virtual protect. These are all stuff you should have seen in the previous video. The first new API call we're going to be calling is create process, and this is a big one, admittedly. Create process is a complicated API call. This one is tough to get right. It's not hard to get right, but it looks intimidating because there's a lot of parameters here. Create process, understandably, has a lot of options. Processes in Windows have a lot of options that you can provide to them when you start them up. Windows knows this is a complicated API, and if you don't really need an option, you can just simply leave it as null, or you can leave it empty or set it to 0, and Windows will simply fill in whatever the default value is. It does have certain things it needs from you, but what it needs is actually very, very minimal. It's just looks a little bit more laborious than it actually is. So let's talk about that. Don't be intimidated by create process. The first thing we need to do is declare a bunch of variables, okay? The first variable we need is the startup info ex structure. This structure is going to contain some information about the process that we want to start. We're going to save that in the SI variable. Then we need a process information structure in the PI variable. This we're going to leave entirely blank. This is for Windows. This is just some space allocated for Windows to populate once it creates the process with information on that process. And we'll see more about this structure a little bit later on because it's useful to us. Then we need two security attribute structures, one for PS, one called PS and one called TS. That's because this one is for the process, the security attribute structure for the overall process, and this one is the security attribute structure for the main thread of the process. The res variable is just a Boolean value. This is just going to store the result of the create process call. It'll be 0 if process is created without error, and it will be non-zero if there is an error code. And then we simply need two handles, one handle to the process and one handle to the thread. It's not as bad, I promise you. None of this is as bad as it seems, okay? Stick with me here. And then keep in mind that each of these structures is not known to nym by default. It is included in the WinIm library, okay? All of these functions and structures and data types are defined in the WinIm library. You can define them yourself, and I gave you an example of that in my previous video. Go back and I feel like a broken record saying go back and watch the previous video, but it's in there if you want to know how to define these structures on your own, but there really is no reason to, or very, very little reason to. I find it's easier just to import WinIm when I need to call the Windows API, and I think most of you will too if you decide to code in NIM. We do need to set a couple of things in a few of these structures, specifically the startupinfo.cb attribute of our startup info ex structure needs to be set to the size of the startup info ex structure. So I'm just getting the size of this structure in bytes and assigning it to this attribute. Okay, very, very simple. Similarly, both of our security attribute structures, both for the process and the thread, have an end length attribute that is the size of the overall structure in bytes. Okay, same thing here. We're just assigning that attribute, the end length attribute, to the size of the overall security attribute structure, respectively, in bytes. All right? That's all you need to do with the security with any of those structures for the purposes of this example. All right? So, create process, again, read the comments if you want to know what every single one of these does. We'll go through the important ones here. We're going to be executing notepad.exe purely as a proof of concept. You can put whatever executable you want here that exists on the system. We pass in our process security attributes. We pass in our thread security attributes. And keep in mind, we are starting the process in a suspended state. So one of the creation flags we need to set is create suspended. And we're also using a startup info ex structure, so extended startup info present needs to be here as well. All right? Other than that, we can leave these two attributes null, and then we're simply giving Windows the address of the startup info structure which is part of the startup info EX structure, and then the address of the process information structure where Windows is going to populate information on the process. Okay? That's it. And that's all Windows needs in order to create a process. Now, because this is NIM, and NIM has some nice things about it, there is another option. If you don't want to go through all of this, if you find this all too intimidating, you can use the start process function in the OSProc library to start Notepad that way. Okay? This is another option that's available to you. Then you can simply call the suspend function, which is also a part of that library, to suspend the process on creation. This will effectively accomplish the same result as calling create process in the manner we just did. You then need to call, or at least you should call, close on that process. It's not going to close the process immediately, but it's going to close it after it finishes its APC thread execution later on after we resume it. So, and it basically all this is doing is telling NIM to clean up all the handles and clean up the process gracefully after we're done executing in it. It's just telling NIM to clean up after us. Now, there are some OPSEC concerns with this. Notably, you need to call open process after this. You need to call another API, which we're not going to cover here, but I'll leave it as an exercise for you if you want to play around with it. The problem with this method is that you're not going to be able to get the handles. You need a handle to the process, and you need a handle to the thread in order to do the rest of the stuff that we're going to be doing here. You need those two handles that we declared up here. And you can get those from the process information structure that Windows will populate for you when you execute create process. But you don't get that structure if you just have nim call start process. So you then need to call open process on the process you just started in order to get those handles, which is an additional API call and a greater surface to be detected on. That's a greater detection. That's a greater detection risk, especially because open process is often associated with malicious activity. It's not always associated with malicious activity, but a lot of malicious activity out there is preceded by an open process call. So keep that in mind. You have to call one additional API, especially because start process is calling create process under the hood. Create process, not create thread. Calling create process under the hood. So you're effectively sacrificing all of this hassle for slightly worse OPSEC, I would say, but that's up to you. I include this for your edification because I feel like it's helpful to know. But since we call create process, because we are big dick Chad energy API callers, manual API callers, we can just take the process info structure that Windows has now populated for us and save the two handles that we need. We need those two handles for allocating memory with virtual alloc EX. Again, we're not going to go into virtual alloc EX, write process memory, and then virtual protect EX again, because these are used identically to in create remote threads. So don't worry about these. Go back and watch the previous video if you need a refresher on these and or read my comments. So we allocate memory in the process. We write our shell code into that allocated memory, and then we make the memory executable. All right? Now that the memory is executable, we call the second new API that we're going to be looking at today, QueueUserAPC. Very, very simple shell call. All it's asking for is the base address, the address at which our shell code is located. Then it's asking for the handle to the thread that you're calling the AP that you're assigning this function to as an APC. And this last one is a pointer to any parameters that the function might require. In our case, we don't need any parameters. Our shellcode is standalone without any parameters, so we can just leave this as a 0. Now, the last new API call is resume thread. This is what's actually going to execute your shellcode. This is going to take the thread out of take the process out of a suspended state, which is going to cause the main thread to start executing its APC functions, one of which is our shellcode, and then before it actually executes itself, and as a result, it's not actually going to get executed itself because of just the way these things work. And then we just clean up after ourselves by closing a few handles. Okay? Very, very, very simple. Really, it's not that bad, I promise. Create process is a complicated API, and we're going to go into create process more in future videos, but try not to be too intimidated by it. You can always leave me comments in the. I've read all of my comments. You can ask questions in the comments below of this video as well. You can ask questions to me on Discord. Don't be intimidated by this. Let's just hop over. Let's see it in action, okay? Let's hop over into Kali. So here's my Kali machine. All right. So here we are. We're going to go ahead and compile. So I've included this compilation command in the actual code. It's in one of the comments in the code. So this is how. There's obviously other options you can include here. I'm not going to go into all the NIM compiler options here, but these are the ones that I would recommend just to keep it simple and also make sure you end up with the right options. So we're cross-compiling for Windows here, so make sure that the most important thing is this tacd ming w, so that you make sure to cross-compile for Windows. We get the success message, meaning the compilation succeeded, and now we can go over to, well, notably, I've got Metasploit running here, listening for connections from Interpreter. So we'll pop into my Kali test machine here. Here is the QueueUserAPC.exe we just compiled. And we're just going to execute this. And I have Process Hacker open here. And I want you, we want to see that Notepad starts up. It even gets highlighted by Process Hacker when it starts. So Notepad has started up, but it doesn't pop up. Notice that no Notepad.exe pops up in front. It's because its main thread is not executing. We suspended it, remember? And instead, we assigned it a new APC function to execute. And if we go back over here, we see that Interpreter Session 2 opened, and we can execute getUID, and we have a fully functional Interpreter shell running in the context of Notepad. It doesn't have to, again, it doesn't have to be Notepad. It can be any process that's on the machine. Okay? So, and if we exit out of here, we close down Interpreter, we will see that Notepad will terminate. Notepad never opens, which is fortunate for us because we don't want the user to be burdened by processes suddenly popping up for no apparent reason. The Notepad never actually appears in the foreground. The user should not be alerted by this activity. It's pretty good at flying under the radar. Pretty cool, right? I'm glad I got to go over that stuff with you. So that's all I've got for you today, my friends. Again, check the description below for links to the code in this video, as well as helpful supporting links and documentation that's going to help you understand it and play with it. If you've got any more questions or comments or threats, bribes, whatever, drop them in the comments or reach out to me on Discord. Or you can just berate me in the chat of my Twitch, like most people do. If you've gained a brain wrinkle or two here, you can really help me out by dropping me a like and or a subscribe. I've got more coming in this series, as well as the more beginner-oriented Python malware series. For now, though, Cthulhu fhtagn, and I'll see you all again when the stars are right. Thanks so much for watching.